Hello everyone, Mr. Hein, and this video I hope everyone is watching because we're not going to prove the definition of sine and cosine. That's more so what I'm going to show you because there's some things in it that aren't necessarily required of us in this class. If you want to see the formal proof of sine of x and cosine x, you're more than happy to try it yourself, look it up. But I do want you to watch this to see where it comes from because you want to understand. You don't just want to take my word for it. And the big question is what's the 1,000th derivative of sine of x? So, but in order to answer that question, what we're going to do, what I'm going to show you in this video, is we want to show, so WTS is college math language, college higher level math language, want to show, I just did that in college all the time. You want to show that for f of x equals sine of x, what's f prime of x, right? So that's not really a want to show, but we want to find what's the derivative of sine of x, and for a function g of x cosine of x, what's the derivative of cosine of x? All right. So let's do sine of x first. Now, before we do that, there's some needed info we need. So some needed background info is we need to know trig addition in order to find the derivative of these functions. All right. So trig addition, the two ones we're going to use sine of, say, a plus b. So when adding two values in sine, that's equal to sine of a, and I believe it's cosine of b. Let me just check, make sure that's right. Yes, and then plus cosine of a sine of b. I don't know, I just have these memorized. I have to reference my sheet to make sure that's right. And then we're going to use cosine a plus b, which I believe that one goes cosine a cosine b. Yeah, it does. Cosine a cosine b minus sine a sine b. And cosine always has the negative, which see soon in this derivative. So we need to know trig addition, and then what you'll also need to know, which this is optional to know, but it's by something called the squeeze theorem. Look this up if you want to know where this comes from, but it's that the limit as h approaches 0 of sine of h over h, well, that is equal to 1. And we also need to know that the limit as h approaches 0 of 1 minus cosine of h over h equals 0. Both of these things can be proved by something called the squeeze theorem. It's outside of our scope, and because of the quick pace of this class and this quarter system, I'm not going to cover it. But I do want you to know what the derivative of sine and cosine is. All right, so let's do sine of x. So f of x equals sine of x. Right. The derivative is going to be the limit as h approaches 0 of sine of x plus h minus sine of x all over h by definition. Simplifying this, now this is where we have to use trig addition. So trig addition for sine of a plus b will give us sine of x cosine of h plus cosine of x sine of h, and all of that is minus sine of x over h. Now what I'm going to do here to find the derivative, right? And do note, the reason I'm using this definition is because remember that the definition of the derivative always works. We can't use the power rule here. You can't use the power rule. This is not a polynomial. Right? So that definition derivative is really coming in handy to understand the derivative of these two functions. Now, where we're at right here in our step is I'm going to do something kind of clever in a way where I'm going to group the sine of x's together So let's write this out to help you see it. I'm going to do sine of x cosine of h minus sine of x. I'm going to group this together. I'm going to group this out here plus cosine of x sine of h. And now remember, what I can do is, since this is just adding fractions, is I can separate those fractions if I just keep common denominators. So I'm going to do them both over h. So notice that it's the limit of all of this. I didn't change the problem. I'm just separating the fractions that are being added here. Now, the limit addition is you can take the limit of each function, or each function for lack of a better word, and it'll still equal the limit of its sum. So what this is equal to is the limit as h approaches 0 of, and I'm going to switch the order right here, sine of x minus, or negative sine of x minus, or plus sine of x cosine h over h, plus the limit as h approaches 0 of cosine of x sine of h over h. And now, what's my next step here? The creativity that is I'm going to factor out a sine x on top in this first one. So then we're going to have sine of x, or negative sine of x I'm going to factor out. And then what we're left with there is a 1 minus cosine of h all over h, plus the limit as h approaches 0. And on this one, recognize that sine of h is just a number. So I'm going to factor that out, sine of h, and be left with, or I'm sorry, I'm going to factor out the cosine of x and be left with cosine of x sine of h over h. And then with these, this rule you don't necessarily know yet, but when you take the limit of something times something else, well, this, since when we plugged in 0, that would just be a number, we can actually factor that out in front. So that would be negative sine of x times the limit as h approaches 0 of 1 minus cosine of h over h, plus, then we can factor out the cosine of x in front, because that, let me rephrase this, make sure you understand this. When we're doing the limit as h approaches 0, the sine of x and cosine of x have no effect on this because h is not part of it, so we can actually factor that out because these are multiplying. Just be careful, because if it's addition, it doesn't quite work the same way because they're grouped together. Multiplying, we can factor that out. It's not affected. Multiplying in the beginning will be the same as multiplying at the end. So you get plus cosine of x, limit as h approaches 0 of sine of h over h. And thus, we have to use our second thing here, where this whole thing, this property, by the squeeze theorem, will equal 0. And this whole limit will equal 1. So now what we have here is that f prime of x is equal to negative sine of x times 0 plus cosine of x times 1. Thus, the derivative of sine of x is equal to cosine of x. And that has some huge implications and importance, is that if f of x is sine of x, then the derivative of sine of x is cosine of x. So f sine and cosine are related. Find the point at any given point on a cosine function, well, then you know its rate of change on a sine function. Right? And remember, sine, cosine, I don't want these to necessarily be functions, these are waves. Sine and cosine represent waves of motion. So when we're starting to understand the rate at which anything that has some wave-like motion to it, the rate of change can be understood by its, either, if it's sine, it can be represented by cosine. So that's the derivative of sine of x. So the derivative, d dx, the derivative of f of x equals sine of x. The derivative, I don't like that way I wrote that. The derivative of sine of x with respect to x is equal to cosine of x. Very big. Now let's look at the next one. I'll summarize these both together. If you hear noise in the background, it's our new Roomba we just got. Woohoo! So f of x is equal to cosine of x. And now let's find the derivative of this. What's the derivative of cosine of x? So f prime of x will equal the limit as h approaches 0 of cosine x plus h minus cosine of x all over h by definition. Then we have f prime of x will equal the limit as h approaches 0, and by trig identity, what cosine x plus h will do is that'll be cosine of x, cosine of h, minus sine of x, sine of h, and then all of that is minus cosine of x over h. Similar to my last proof, I'm going to group these together where I'm going to put the cosine of x's together, these two in front, and then put that separate. So we have the limit as h approaches 0, and then make it separate the fractions that are being added there. So we have cosine of x, cosine of h, minus cosine of x all over h, plus negative sine of x, sine of h, all over h. And then we can apply the limit to both of them, and I'm going to factor out the parts that aren't affected by the limit here. So what we'll have here is that what we can factor out there is a cosine x, which is not affected by the h in that. So I'm going to put that in front, cosine of x, the limit as h approaches 0 of cosine of h minus 1 over h, plus, and then I'm going to factor out a sine of x here, or a negative sine of x, of this limit here, sine of h over h, because that's not affected by the h. And this whole thing by the squeeze theorem equals 0. This whole thing by the squeeze theorem equals 1. So what you have here is f prime of x is equal to cosine of x times 0 minus sine of x times 1. Thus, f prime of x is equal to negative sine of x. And the significance again of that is that if f of x equals cosine of x, f prime of x will equal negative sine of x. And there's the second part of this. So if I put it all together, well, before I even talk about it all together, so that means if we have a function cosine of x, well, it's almost related to sine of x, but the negative version of it. And that's something you're going to want to memorize and know. So in summary, we have here the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to negative sine of x by the proofs above, with one part, this part right here, you could look up if you want to know how those are proven by squeeze theorem, but we're omitting that from this year's curriculum. All right? So there it is, very big. You're going to want to more or less memorize that. Hopefully it comes naturally. Hopefully it comes naturally the more you use it. But there you go. The derivative of sine of x is represented by a cosine function. The derivative of cosine is represented by a negative sine function. So these waves, we can analyze its rate of change by another wave. Interesting enough. All right. Hope that makes sense to you. That's what you want to know by the end of this video. All right. And maybe all of these proofs that we did prior could show up as an extra credit question.